not differentiable, and at this point, the derivative has a jump. The derivative is not continuous because the left-hand side of the derivative has a slope, or is a slope that of -2, and this one is much smoother. This is more acute, and this is less acute. This is closer to 0 than this one, right? So at the point with x equals 2, the derivative will have a jump. On this side, -2, on this side, -1. So therefore, the original function is not differentiable at 2. So now, final step, we are asked to graph both. And the way we graph both has to be exactly, please leave room because we need to graph both one under the other. So the y-axis has to continue. So this will be the function, and this will be the derivative. I just want to make sure, I wanted to say this first before I create the table. So make sure that you have this continuing, because the points here will transfer here. Whatever points I find, they will have to be one under the other. Okay, and now I will have to create the table. So I have x, I have g of x, and I have g prime. Okay, where is my function? So I have 0 and 2 are the key, 0 and 2. And 0 has a bracket to the left and a parenthesis to the right. They're touching. And then the same thing on the other side, but a parenthesis and then a bracket. This piece uses 2x. This piece, 2x minus x squared. And the last piece, 2 minus x. So let's find some points. So for -1, what do I have here?
-2.
Good. And for 0 in here, inside the bracket?
0.
Good. Inside the bracket on the other side, we already determined that is still 0. 2 on this side, we already determined that is 4 minus 4 is 0. We already determined that, so obviously the function is continuous. I'm going to put 3, and this will be -1. So from -infinity to infinity. They were all determined because we studied the continuity. So the limit from the left, limit from the right, left and right, and so on and so forth. I'm going to also put another point in here or another value, so it's 1. So 2 minus 1 will be 1. These are linear, this is quadratic. It has a maximum because the leading coefficient is negative. So this piece will look like this, only between 0 and 2. Okay, so let's graph that. So I go back to F right here. So I plot -1, -2. That's first. -1, -2 is this point. Then I plot 0, 0. And this side will be in orange, and it's a line, straight line. Okay. The next piece in blue. So 1, 1. And then 2, 0. And I know that the vertex is right in the middle because the x-intercepts are 0 and 2. So that's exactly the vertex. So because this should be an open point, but since this is also 2, 0, I am going to just graph that piece. Okay. Now the last piece in a different color, let's say red. And at 2 is 0, and at 3 is -1. So here's the graph. I used 3 different colors just to refresh your memory that we cannot overlap anything here. I haven't looked at your graphs, but I'm hoping that you did not continue this, and you didn't have a quadratic, and then you didn't have this, and all this over there, because that would break my heart. Okay, so this piece, and this piece, they cannot overlap because this is a function. Okay, now, so I'm going to go back to the derivative at this point, to the left-hand side of 0. So I already know that this function, g function, is differentiable at 2, so the derivative will be continuous at 0. Continuous at 0, not continuous at 2. See, the left-hand side and the right-hand side are 2. So, now this piece, maybe I should put it underneath here. Okay, so this piece will use 2. This piece will use 2 minus 2x. And the last piece will use negative 1. Okay, so because I forgot one important thing here, because the function is differentiable at 0, now I can put in the equal symbol. I can put it back. I cannot put it here because I established the fact that the function is not differentiable at 2. So I cannot put the equal symbol where it was. That's gone. But here I have to, because the function in g of x is differentiable at 0. So it's the same symbol here, but here, parentheses on both sides and nothing in the middle. Nothing. Okay. So to the left-hand side in 2, I can plug in anything. I get 2, no matter what. I can plug in 0. I have to get 2. I will plug in 1, and I get 0. I will plug in 2, and I get negative 2. I will plug in 2 as expected. I get negative 1, and I get negative 1. So now I'm ready to graph the derivative. The corresponding orange, the slope is 2. So for every point in the orange, it will be 2. So when x is 0, y is 2. When x is negative 1, y is 2. Everything will be 2. This is the derivative of the orange piece. Now the blue piece. The blue piece is a linear function with a negative slope. And I have the point 0, 2. I have the point 1, comma 0. And I have the point 2, comma negative 2. So 0, 2, 1, 0. Right here, this one. Of course, because the slope here is horizontal. And the tangent is horizontal. So of course, the peak will have a derivative of 0. And 2, comma negative 2. But of course, with an open point. So here's the derivative of this piece. It's quadratic, of course. Its derivative has to be a line. Finally, I reach the red piece, and the red piece is negative 1, negative 1, negative 1, negative 1, negative 1. This is a linear function. Of course, its derivative is a horizontal line, constant. This is a linear function. Of course, its derivative is constant. This is a quadratic function. Of course, its derivative is 1 degree less, which is a line. So the original function here has a unique slope, but here has this slope of negative 2 and this slope of negative 1. Therefore, the function has a corner here, which translates into its derivative having a jump and not being defined there. That was a long problem. Sorry. Any questions?
I have a question.
Please.
The bracket that you put down for g prime of x, we weren't sure to put it down on initially, so what was it that decided to put it on the 2x side for?
We determined the fact that it was differentiable. The function is differentiable. The limit from the left.
Can we do close parenthesis and then an open bracket instead of an open bracket and then a closed bracket, or closed bracket and an open parenthesis?
No, because the original function had the equal symbol here.
Okay.
Very good question. Is that clear? I cannot move it from there anywhere else. Although you could say, but it's continuous, what does it matter? It doesn't really. I could put it here. But on the original, it was at the first one. But it doesn't matter. You can change it if you want. You can put the parenthesis and the bracket. It will not be wrong. But I wanted to stick with what the problem was giving us. If it's continuous, it doesn't matter. You're correct. I can move the equal symbol here. Good. Anything else? Anything else? Okay. Moving on. The next step, the product and quotient rules, that's 3.1. Which page am I on? I know I talk too much. Okay, page 6. So product and quotient rules. I was just gonna mute you, Lindsay. Okay, perfect. So if we have two functions that we differentiate, do not try to invent anything here, please. So the rule is f prime times g plus f times g prime. You can twist this the way you like. The rule in the book is showed slightly differently. It's up to you. I prefer to keep everything in the correct order in my mind. You can choose your own order, and I'm fine with it. 1, 2. 1, 2. 1, 2. Your book says 2 prime 1. It's fine. Same thing. So let's apply this rule in any problem you would like in 3.2. You can choose anything from 3 through 26 as long as it's a product. 3 to 26 in 3.2, and of course I wrote 3.1 because I talk too much. Okay, as long as it's a product for now. Okay, 1, 2, 3. I'm going to choose this one. F of y equals 1 over y squared minus 3 over y to the 4th times y plus 5y to the 3rd. And you could say, it's very simple. Just distribute y to these two, distribute this to these two, and forget about the product rule. I agree with that. But we want to practice the product rule. So we are asked to find f prime of y. And we're going to use the product rule. Before I start, I would like to talk about the derivative of 1 over x or 1 over y, doesn't matter. You can say, where is 1 over y here? There isn't. Because I would like us to remember it, and then we'll move on to any other power other than 1 in the denominator. So let's talk about 1 over x prime. Because again, this is going to be carved in stone moving forward. Well, I don't know how to differentiate a quotient yet. I will in a minute. But right now, I don't know how to do it. But it's very simple because I will change this into x to which power?
The -1.
Very good. Thank you very much. So this is the power rule now. So I bring -1 down, and so I subtract 1 from the power. What do I get when I subtract 1 from the power?
-2.
-2. And I should write times x prime, but we know that that's 1. Thank you. So this is the same with -1 over x squared. So moving forward, like the square root of x and e to the x carved in stone, to remember. Okay, so the square root of x prime is 1 over 2 the square root of x. E to the x prime is e to the x. And 1 over x prime is -1 over x squared. These have to be carved in stone, please. So now I can go back to my f of y. And yes, I will not differentiate this. I will differentiate y to -2. I will not differentiate this, but I will differentiate 3 times y to -4. So I will rearrange the function. So always remember to simplify as much as possible.